Hey there, welcome to this episode. So today, I'm going to change my teaching style a little bit. So if you're used to my videos, I have this big black screen where I'm just talking about a particular topic. It's very formal. It's lecture based. But I'm kind of thinking about this changing this style, changing the way I teach. I think it's much helpful to students if my videos or the teaching videos are slow paced. There's much more informal communication in there. So for this particular episode, I've decided to pick up one of my most favorite topics. It's a very simple topic. But I believe students will find a lot of value in this topic, and that's what I've kind of experienced over my teaching career. So for your test preparation, the first topic that I've chosen in these style of videos is basically weighted average. So we all have encountered questions related to weighted average, not just in your test preparation, but also in real life. Like you kind of take averages of different groups. That's essentially what weighted average is. So when you have different groups and or each group has different average, then you want to calculate the average of that particular, all those groups together. So, I have this example here. So imagine you got, 100 cows and each cow weighs 20 pounds, just imaginary, there is, I don't think you'll find a cow weighing 20 pounds. But you have 50 horses which weigh 60 pounds. And you can see that the denotion here is, this is N1, this is A1, this is N2, and this is A2. So that's typically the structure of a weighted average question. So you've got 100 cows, each weighing 20 pounds on average, and 50 horses, each weighing 60 pounds on average. And you want to take the average of all of them together. That's what weighted average is. And if you were to calculate the average of 100 cows and 50 horses together, that will come out to be, summing up the weight of all the cows, summing up the weight of all the horses, and then dividing by the number of horses and cows. So that essentially gives you the average of all the cows and all the horses, right? And if I were to put this in an algebraic structure, that would actually mean this. So the average A, which is the average of both the groups put together, you can have more than one group, so that's not really an issue here. And this is essentially the algebraic explanation of both the groups put together. So you got A is equal to N1 times A1 plus N2 times A2 divided by N1 plus N2. And that's exactly what I'm doing here. This is N1, this is A1, and this is N2, this is A2 divided by N1 plus N2. Now, why do I start with such a simple explanation or such a simple example? Because if you were to solve weighted average questions and in your test preparation, if you're writing the GMAT test, the GRE, or any other test, in your test preparation, you're not going to see straightforward questions. The questions are going to be very, very difficult. They're not going to be, they're asking you to find the average of cows and horses put together. So there is a way to kind of visually see this algebraic expression and kind of get the question done very easily. In order for me to reach that visual representation, what I'm going to do is I'm actually going to start with this expression that we have here, that A is N1 A1 plus N2 A2 divided by N1 plus N2. So I'm just going to start from here, and what I'm going to do is I'm going to manipulate this algebraic expression here. So what I'm going to do is, first thing is I'm going to take this N1 plus N2 on this side, and when I do that, this is the algebraic expression that I get. And then I'm just going to bring this N1 to this side and bring this N2 to this side. and I eventually end up with this. And then I'm going to take the n1s out from here and the n2s out from here, and I'm going to end up with this. And eventually I'm just going to bring the n1s together and n2s together, and that it looks like this. So this is just basic algebraic expressions that we've seen, and we actually end up at something very interesting. Now this expression here can actually be written in some sort of a visual representation. So that's basically, if you have a group which has an average A1 and you have another group which has an average A2, so think of A1 as your cows and A2 as your horses. Cows average is 20 pounds and horses average is 60 pounds, so those are the averages. And if you mix them together in some sort of proportion, like you have 20 cows and 60 horses, so that's a proportion. If you mix them in some sort of proportion, you end up getting an overall average A. That's what you end up getting, which is the overall average of both the groups put together. And if you just kind of translate this expression into here, you can easily say that N1 is going to be A minus A2. So N1 is going to be the difference between A2 and A, of course a positive difference. And N2 is going to be difference between A and A1, right? So that's what a visual representation of this algebraic equation, this algebraic expression here is. It's basically, I'm just going to repeat myself again here, is that if you mix two groups together, one group is A1 and one group is A2, and you get overall average as A, then A2 minus A1 will actually give you N1, and A1 minus A will actually give you N2, and then you can easily actually get the proportion. And this is basically the proportion. This is not exactly the N1 number, but that actually tells you in what proportion or in what ratio N1 and N2 are mixed together. So that's essentially what you get, and this is what we call allegation. That's what we call allegation. So that's what it is. And this can be used in so many different ways. You're not going to believe it. I'm just going to show it to you in different instances. So whenever you see an allegation question, just think about this visual representation, and you will be able to solve a lot of questions very quickly. So I'll just start off with one very easy question, which is an average question, which is, so you got girls and boys in a class, assuming there are only girls and boys. The average height of girls is 156, the average height of boys is 174. If girls and boys are mixed together, the average height is 160. So what's the ratio of boys and girls in the class? So that should be easy. So you're mixing a group of girls, whose average is 156. And you're mixing it with a group of boys whose average is 174, and you're actually getting an overall average of 160. So in what ratio you should be mixing them together? Well, that's going to be easy. So you just have to do this minus this. So what is 160 minus 156? 4. So just take the positive number. And this minus this, what's 174 minus 160? Well, that's 14. So they are actually mixed in 14 by 4, or you can say, you can eliminate the 2 out. You can say that it's actually mixed in 7:2. So for every 2 boys, there are 7 girls. That's the ratio in which this class is mixed together. So if there are 2 boys, there are 7 girls. If there are 3 boys, then there are 21 girls. If there are 4 boys, then there are 28 girls. So you get the rhythm here. So that essentially is allegation, and you can see that it's so useful in doing these questions. I mean, you don't have to write any algebraic expression. You don't have to calculate complex multiplications. It's super useful, and just understand that this average is kind of stuck between these two numbers, because if you mix two things together, the overall thing is always between the other two averages. So if you mix two averages together, the average is always between both averages, so it's always greater than one and smaller than the other. So, it's if you, let's suppose if you mix 100% alcohol with 100% water, you're never going to get complete water or complete alcohol. You're going to get something in the middle right there. So there's that. So this is one of the ways this allegation applies. Another way this allegation applies is you'll see a lot of profit and loss questions, where you got people mixing two kind of things together in terms of their cost, and you get an overall cost. So so for instance, this is the question here. It says David bought a rice for should be a rice bag. David bought a rice bag for $30 per pound and the other type for $50 per pound, and if we mix both of them together, the overall cost is $33 per pound. So calculate the ratio in which the quantities are mixed. So you get the point here, right? So what's happening? So he mixed one group of rice, let's call it R1, at $30 per pound, and he mixed the other group of rice, which is R2, which is $50 per pound, and the overall mixture is just $33 per pound. So you want to find out in which ratio these quantities are mixed. So you can see the difference here is 3 and the difference here is 17. So for every 3 parts of the expensive rice, he has to mix 17 parts of the inexpensive rice for the cost to come out at 33. So yeah, there you go. That's the answer. So profit and loss, average, it will also apply to interest questions, so basically wherever you got two things coming up together and mixing together, you're gonna apply allegation there. So in here, Danny won a lottery. Good luck to you. He invested some parts in mutual funds, which gave him 6% return, and he invested the other part in gold, which is 13% return. Looks like the economy was not doing so well, so he earned an average of 10% from both investments. So again, you got two things. You got mutual funds, which were invested at 6% return, and then you got gold, which was invested at 13% return, and you got an overall 10% return, right? So you can easily apply allegation here. You can say this minus this here is 3, and this minus this here is 4, so that means they must be mixed in 3:4. So for every 4 parts of gold, for every $4 in gold, he must have invested $3 in mutual funds. Simple as that. So let's see what other applications it has. So the next is time, speed, and distance. So you've got if you actually look at how average speed is calculated, so for instance, if you travel for S1 speed for T1 time and S2 speed for T2 time, this is the expression for average speed, and you can see that it sounds very familiar. It's exactly the weighted average of both the speeds. So essentially you can apply allegation here too. So you send a vehicle to moon traveling at 1,000 miles per hour, then it further went to Mars at an average speed of 2,300 miles per hour, and the overall average speed was 1,800 miles per hour. So you got to calculate the ratios there. So that's super easy. So you're traveling 1,000 miles per hour at one particular distance, then you're traveling 2,300 miles per hour at one particular distance, but your overall average speed is 1,800, right? So there's that. You know what, I can just get rid of the zeros here. I don't need to get there, so I can just get rid of the zeros everywhere. So the ratio is this minus this is 8, and this minus this is 5. So just take the positive number, don't worry about the negative part of it. So for every 8 parts of for every 8 hours of this speed traveled at 23, you will be spending 5 hours at 10 miles or the other side of it. So the ratio is 5:8, right? So you get my point. So what I'm saying here is that I'm hoping you're getting my point, that it applies to average speed, right? Pretty fun. Now let's see where the other aspects it applies to, which is mixtures. That's where this expression of allegation really came out to be. So in here again, John has a solution which has 60% acid, and Jean has a solution which has 90% water, and the rest is acid. So they mix both the solutions together, and the resultant is 40% acid. So again, you can do that. So if you I just gonna type John here. I'm just gonna type Jean here. So John has 60% acid, so that's 60% acid, and Jean's solution has 90% water, and rest is acid. So you gotta make sure that you're comparing apples to apples here. You're comparing acid to acid here. So if it's 90% water, that means this is gonna be 10% acid here, and if they mix both together, the resultant concentration is 40. And now you can just get rid of the zeros here. You don't need the zeros if there are zeros in everywhere. So you can say this minus this is 3, and this minus this is 2. So it's mixed in 3 to 2 parts, right? So there's that. That's super easy. So you can see that it applies to mixtures as well. So whenever you're applying, mixing two things together, you're going to end up having some things together. And you can apply that from a water perspective too. Like for instance, John's solution is 60% water. I'm assuming 60% acid. I'm assuming, it's 40% water. So it's 40% water. Jean's solution is 90% water. And overall, since the resultant solution is 40% acid, that's going to be 60% water. And if you can see, that still comes out to 3:2, right? That still comes out to be the exact same thing. So even if you take it from a acid perspective, or you take it from a water's perspective, so whichever perspective you take, you're going to end up getting the same answer, which is the beauty of this expression here. So yeah, so it applies to mixtures, and you're going to see a lot of questions. So I had a lot of students writing their GRE exams, their GMAT exams, and their CAT exams and whatnot, and they always get at least one question where you have this weighted average, and I'm personally always happy whenever I see a weighted average question, because that's like a sure shot answer. You're gonna get it because it's so easy to solve questions like these. And then questions can tell you if they can kind of augment the question a little bit. They can say, okay, if this is in 3 parts 2, if this is 40 grams, how many grams is this one? So you can easily use the ratios to calculate that out. I mean, if this is 40, then this is 60, because it's actually mixed in 3:2 there, right? So that's something that you can pretty much do. Okay, so I'm just going to solve the GMAT official question here. So it says that seed mixture X is 40% ryegrass and 60% bluegrass, and Y is 25% ryegrass and 75% something else. If they're mixed together, you get 30% ryegrass. So you can see, the same things are happening here. So you have a mixture X and you have a mixture Y, and let's just stick to the ryegrass here. So this X is 40% ryegrass and blue is 60% ryegrass, and you kind of mix them together, you end up getting 25% ryegrass. 30% ryegrass. Oh, no, I'm mixing it up. X here is 40% ryegrass, right? So X is 40% ryegrass, and you've got mixture Y, which is 25% ryegrass. So there's that, and you mix them together, you get 30% ryegrass. So that's what it is, right? A lot of extra information provided there. So this minus this is 5, and this minus this is 10. So you can see that. So that means it's mixed in 1:2. And the question is telling you what percent of weight of this mixture is X. So for every 3 parts, 1 part is X. So you can safely say that it's 1/3 of the mixture, which is X, right? And 2/3 of the mixture is Y. So yeah, so you can see that, you know, this shouldn't have taken you 30 seconds, you know, or more, or maybe at most a minute. So these kind of questions are, you know, they're very easy to solve, and these are opportunities for you to save some time, for you to get those points. Okay, so I don't have any other question. So yeah, I mean, I'm just gonna discard this. So I mean, yeah, this is a great technique. You must practice it. You must practice. You should have some set of questions that you practice on this particular technique, and once you get good at it, you can just put this aside, because these are points that you need to score. So whatever tests you're taking the GMAT, you're taking the GRE, you're taking any test which involves quantitative reasoning, you're going to get questions like these, and you should be able to solve them pretty easily. So guys, tell me in comments, how did it go? This is just an experiment that I took. This is a new way I'm actually making videos now, and tell me what kind of videos you want me to make, what topics that you want me to cover. Kind of help me out here, so that I can focus on the right topics. So that'll be it, guys. Thank you very much, and I'll see you in the next one.